I'm just going to do, this is going to be like 6.3 through 6.5 because this all, like I said, kind of goes together. But it's stuff about graphs of sine, cosine, and tangent. So we did the parent functions for all of them, but the only ones that we're going to be looking at there, like shifting and what's happening, are going to be the cosine and tangent ones. Tangent ones, we really don't do a lot with the shifting. We just look at where would their vertical asymptotes be and what the period of it is, which is basically what completes one full cycle. So our general form of I'm going to start with sine and cosine, would be y equals a sine of bx plus c, or not plus c, sorry, minus c, plus d. And cosine would be y equals a cosine of bx minus c plus d. And these b values, these b values could also be outside the parentheses, not going to change anything. Sometimes they put them in, sometimes they put them out. So I go back and forth by whatever the book is doing at that time. So we have some steps. I actually want to grab my... the steps that go with these ones better, so I'm going to use them. All right, so basically we're going to be looking at the steps to solve these things. Well, yeah, we'll just do it as the steps. All right. And these steps will apply to sine and cosine. The only difference in the two is where their starting point is. Sine always starts at 0. Cosine always starts at our amplitude. So steps to graph sine and cosine. Step 1, using the a value, determine the amplitude which is the absolute value of a. So that's the number in front. Now the reason they do absolute value is sometimes a might be negative, but our amplitude is always a positive value. That's how far away from the origin basically are we going to oscillate back and forth between. And if it's negative, that's going to mean something totally different in step 6. Step 2, using the b value, find the period, which is one full cycle. So anytime I'm asking you to graph the trig functions, I'm only looking for you to graph me one full cycle. We could go on forever in both directions, but I don't need to do that. So the formula to find the period is 2 pi over b. Some people say absolute value of b because the period also has to be positive, but I will say in the last couple of weeks doing graphing trig functions in different classes, I have not had a single time where b was negative, so we haven't had to worry about that. So just know that the period has to be positive either way. But the general formula that they tell you is just 2 pi over b. They don't usually say it any other way. Step 3, to figure out how to scale the x-axis, divide the period by 4. Wow, I can't spell. Okay, so normally on the parent functions, our period is 2 pi, and so we've obviously done 6 different times now. We count in increments of pi over 2. So it's pi over 2, pi, 3 pi over 2, 2 pi. We could keep going. But sometimes our period is something really weird, and we need to know what, like how to scale it. Scaling used to be, I would say, the absolute hardest thing for me when graphing trig functions. So I wish somebody had told me this formula way back when, instead of me sitting there guessing what the period, well, I knew what the period was, but then guessing, okay, what's half of that, and then finding that other value that goes in between there. It was just a pain. If I had this formula, it would have been so much easier. So this would be, we take whatever our period is and we divide it by 4. So that's why when our period is 2 pi on those parent functions, we divide it by 4. That reduces to pi over 2. And so the scaling is pi over 2, and that's where we get 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. So that's where we get that from, and we can just keep counting it that way. So then we're getting into the stuff that is related to, in this formula, C and D, and then if A was negative, we'll get into that as well. So step 4, using the C value, shift the appropriate units left or right. Now, if you remember back to graphing parabolas, it follows the exact same form. If the sign inside is positive, it goes to the left. If it's negative, it goes to the right. So I like to say it goes opposite the direction of the sign. So if C is positive, then it goes to the left, however many units. If C is negative, then it goes to the right. So again, that's what's inside the parentheses. That's that BX plus or minus C there. And that's telling you if it's going left or right. And fortunately, a lot of times they're nice to us, and they'll do it in increments of like something related to pi. So it's not, nice. The pre-cal book is not that nice, and sometimes they actually give you whole numbers, and you have to sit there and try to guess when you're graphing them how far over I need to shift it and all of that. Step 5, using the D value, shift the appropriate units up or down. And this one goes the same direction as the sign. So if D is positive, it goes up. If D is negative, it goes down. So outside, it goes the same way. Inside, it goes opposite. And then lastly, step 6. Determine whether or not the graph is reflected. So if A is negative, the graph flips over the x-axis. So it takes the whole graph and it just flips it upside down. So we are going to do, just in case y'all do take pre-cal, we're going to do some where we're graphing them, and some of them you're just going to say what's happening to them. So we'll just like state like, okay, this one has an amplitude of this, period of this. I would scale the x-axis by this. It shifted, left, right, up, down, whatever it is. It's reflected or not. And then some of them will actually take that information once we've written it and we'll actually like physically graph the stuff. But I'm going to go ahead and do the notes for tangent, and then tomorrow we'll actually pick up with some of the graphing and stuff like that, but that way we have all the notes together for that. So this stuff up to this point has been 6.3 and 6.4 technically. I have to see which I have the notes as like literally 6.3 and 6.4. So this next stuff would be out of 6.5 in regards to tangent, just so that we're aware. So the tangent problems that you'll get probably tomorrow, a few of them for homework, depending, will come out of 6.5. So it's more just informational for you. Come on. All right, so characteristics, because we're not actually graphing characteristics, okay, of y equals a tangent of bx. So we don't actually graph tangent other than the parent function. I just want us to know where would the asymptotes be and what is the period, because tangent's a little different because the graph always looks the same. It's just how quickly it basically gets like taller. But if you go on to take pre-cal, they don't really expect you to be able to graph tangent. They just expect you to be able to graph sine and cosine as far as like the AP exam. So I just like us to know like the characteristics, because they could ask us that information as like a multiple choice question in pre-cal. I know this isn't pre-cal, but we're getting there. So I just want us to be familiar with that as well. And if we did in this chapter, it would be super short, as y'all have already seen. 6.1 and 6.2 is really the only math stuff. The other stuff is just graphing. So, anyways, the period and vertical asymptotes. Just as a reminder, we abbreviate that VA, not Virginia, but, of the graph. Of y equals a tangent of bx, where a and b are non-zero real numbers, are the period is equal to pi over the absolute value of b. So in this case, they do put the absolute value bars, which is kind of interesting anyways. But same thing like with the other ones, the period has to be positive. Obviously, we can go in the negative direction, but the period itself is positive. And that's the same thing. It's the time to complete one full cycle. So the only difference between sine and cosine and tangent is that sine and cosine, the period is 2 pi over b. Tangent is just pi over b. And then vertical asymptotes, I'm just abbreviating that, are at odd multiples of pi over 2 times the absolute value of b. So again, obviously we can go in the negative direction, but technically vertical asymptotes are positive. So they're at odd multiples of that. So that's why it was at like pi over 2 and 3 pi over 2, 5 pi over 2, but it wasn't at pi and all of those things. It wasn't an even one. So anyways, so like I said, on those ones, we'll strictly be just answering questions of like, what is the period? What are the vertical asymptotes? Sine and cosine, we'll do a few graphing ones, nothing super crazy, but just to kind of give you a baseline so that you've seen it next year. I tried with Algebra 2 this year to give them like a baseline. I only sort of did that last year with the class, and so I feel like graphing for them was a little harder this year because they hadn't done it before much. So I just want us to get that like little baseline of just what is it in case we end up there next year. Not that I'm expecting you'll remember all of it. I always have to refresh on trig graphs because they're just very different than everything else. But any questions about any of this at this point? All right, well, we don't have we have like 10 minutes, but I don't want to get into that would probably get us through like one example, being that it'll be the first one and we're going to talk through step by step. So I'm just going to hold off at this point. If y'all have something you need to study for or work on, you can do that. And then we'll pick up examples tomorrow and probably into Monday. And then remember, we're going to do that parent function quiz on Tuesday. So you'll need to be able to graph all 6 parent functions. You can do it on 4 graphs, doing sine and cosecant together and cosine and secant on the same one. But that's going to be on Tuesday. So you have all of that stuff to this point so you can start studying for that as well. And the easiest way is just like give yourself a blank piece of paper and be like, can I graph all of these? Because you won't have any information. You basically get handed a blank sheet of paper. So it'll say like graph the 6 trig functions, but that's pretty much all it's going to say. So it's the easiest way to practice and make sure you know what you're doing, and then go back and look at compared to your notes to mine match exactly, because that's all I'm looking for. So match exactly. So any questions about that? No.